guys. This is 700 Club Worksheet 2. So the book we're working on calls this probabilities. I would call these two-way tables, but the reason why it's probabilities is that you see how these answers are numbers between 0 and 1, and that's the likelihood of occurrence based on the information collected. So let's get started. The first question here says, the number of fish species were collected, cartilaginous and bony. That just means has cartilage or is mostly bones. So I think sharks are made mostly out of cartilage. So you kind of think of these as the same structure as sharks, and then this is fish that have bones. Okay. All fish can be categorized as either the cartilage or the bony type. In the data shown above, these were produced by biologists studying the fish species in 2 locations, Philippines and New Caledonia. Assuming that each fish species has an equal chance of being caught, now this is the important part, we got to read the probability of catching a cartilaginous fish in the Philippines is how much greater than the probability of catching one in New Caledonia. So what is it they're asking? Well, they're asking you to compare the probability that it's a cartilage fish given it came from the Philippines and compare that to the probability that it's a cartilage fish given that it came from New Caledonia. Okay? So we need to calculate both of these in order to decide how much greater this one is than that. Let's go. Now, any two-way table, we usually need extra room, and I'm kind of running out here. So we have 400, 300, 700, 800, 1200, 2000, okay? And these are our totals. Okay? Now, what is the probability it's cartilage given it's from the Philippines? So out of the 1,200 that came from the Philippines, 400 of those are cartilage. Out of the 1,500 that came from New Caledonia, 300 are cartilage. So to compare, we need to have like denominators. So let's reduce these fractions a little bit here. So we have 4 over 12 compared with 3 over 15. Well, we can still reduce this more. This would be 1/5. This would be 1/3. So comparing 1/5 to 1/3, 1/3 is greater, but we need common denominators. So if I multiply the top by 5 and the bottom by 5, the top by 3, the bottom by 3, we now have our answer. We have 5/15 compared with 3/15. So that would mean that this one is 2/15 greater. A. Next, the incomplete table summarizes the wildfires that occurred in 2 regions of Africa in 2014. What fraction of all wildfires in East Africa were human? All right, so they're asking, what's the probability that it was human given it came from East Africa? All right. So using the complement rule, just means the 2 numbers, there was only 2 things measured. It was either caused by human or by lightning. So just subtracting, working our way backwards, we can say this had to have been 85, knowing that this had to have been 55. knowing that this had to be 120, knowing that this had to be 100, knowing that that had to be 70. Okay? Now, always double check your math, adding vertically and horizontally so that everything adds up for sure that you didn't make a math mistake. And it looks pretty good. Okay, so now we can answer the question, what fraction of all wildflowers in East Africa? So I'm only interested in the wildflowers in East Africa. So given they came from East Africa, what is the fraction of the wildfires that were human caused? And now I have to figure out which one. Now there's a couple strategies, but you can turn this into one strategy, turn it into a decimal. I get 0.5416 repeating. Now keep in mind, these types of questions would show up on the calculator portion of the test. So if I'm looking here, I also see that a 5 is in both numbers. So I can just divide 5. I get 13. And divide 5 again. I get 24. And that is my answer. To reconfirm, 13 divided by 24 is this same decimal. All right, next one. A manufacturer used 2 assembly lines to produce air conditioners. The result of each assembly line quality control is shown above. If a refrigeration from the manufacturer turns out to be defective, what is the probability that the refrigerator was produced by assembly A? So we're only interested in whether or not it's defective. If it is defective, so given that it is defective, so what's the probability that it came from assembly A, given that it is defective? Okay. Well, technically, this is a typo. These should be decimals between 0 and 1. This is actually the percentage, but anyway, I'll have to write the company here. But 300 out of the 800 defective that were measured came from A. So if we turn this into a decimal, and then we turn it into percentage, that'd be, we would assume that about 37.5% of them would be defective from that company. Okay, 11. The table above summarizes the distribution of living situations in a neighborhood if a duplex in the neighborhood is to be inspected at random. So if we are looking at these 46 duplexes in this community, what is the probability that the residence is occupied by no more than 2 family members? Okay. So the crux here is, what does this mean? Okay, no more than 2 family members. So 3 people living there has more than 2 family members. 4 people living there is more than 2 family members. So these 2 situations, okay, so what's the probability of no more than 2 given they came from a duplex? Okay. So 46 in the denominator, and now we have to combine this 22 and 12, making 34 over 46. Now we notice both of these are even numbers. So if we divide by 2, we get 17. Divide by 2 again, we get 23. 17 over 23. Ta-da. This one's going to take a little longer. Let me try to. All of these are going to take a little bit longer, but these are harder. Okay. A table above shows the results of a test that's designated to give a positive indicator when a patient's infected with a certain virus and a negative if they're not infected. According to the results, what is the probability that the test gives an incorrect indication? Okay, this is a common question, and you kind of got to wrap your brain around it first. So when I look at the table, I think about, and every test that's ever been made has to publish their accuracy. So there's two ways to be wrong. All right. And we're looking for both ways to be wrong. So let's take a look. It says, let's say we have a way of figuring out you have the virus. All right. 30 people have the virus but tested negative. So that means they got it wrong. The test got it wrong. So I'm going to highlight the test was negative, but it should have been positive because we know they have the virus. 370 tested positive, but that's correct because you have the virus. So it looks like most of the time the test works accurately. Now, these people don't have it, don't have the virus, okay? And that's good. 550 people don't have it, and the test said, yeah, you don't have it. You were negative. So this was correct. But these people were tested incorrectly. They don't have it, but the test actually tested positive. So the test got wrong. All right. So now they're saying, according to the results, what is the probability that the test is wrong? Well, there's 1,000 people tested and 80 were wrong for two different reasons, but 80 were wrong. That 80 over 1,000 is 8%. Check out the next video for the last 3 questions.